Bismillahirrahmanirrahim. In this video, we'll be discussing example 17.8 from application of Fourier series, book by Mr. Alexander and Sadiku. This is on the request of a student from Bangladesh. So let's see. Now the question says that we have to find average power supplied to the circuit. So the power is being supplied by this source. This I have just converted into polar form. And the formulas given in the book are, this is for the power supplied. So the DC power, and this part is the AC power. And so we have to calculate them separately and then find the total power. Now, one thing different here, we have learned that for the power, we write the phase angle as cosine of theta V minus theta I. That means this is the angle of the voltage and this is angle of the current. But in this case, since there are many frequencies, like N could be 1, N could be 3, 5, whatever, and therefore they have used two different signs, and that is the theta is used for the voltage angle and phi is being used for the current angle. Then there is another technique that has been suggested in the book, that is we can find the power absorbed by the resistor, this power, DC power absorbed and the AC power absorbed, and the two will be same. So the power supplied should be equal to power absorbed. So we'll do by both the techniques. So this is the question: determine the average power supplied to the circuit. If I is given here, and this is the circuit. So the first thing we'll do is convert the circuit into phasor domain. The small I will become capital I, small v, capital V, and capacitor will now be 1 over j omega c or 1 over j2 omega. And since omega is different, now you can see here omega is 1, here omega is 3. So we have to work with them separately. So we are keeping omega here because with every value of omega, this value will change. Okay, so first of all, we'll find the DC value. Find the input impedance. So the impedance will be parallel of these two, and that we can easily solve. Solving and further solving, this is the answer. Now you can see the denominator is in complex form 1 plus j something. So we should convert this into a polar form. And we are used to this type of equation, that the rectangular x plus jy, or the complex form, can be written as magnitude and phase angle, where the magnitude is under root square of the two terms and the phase angle is tangent inverse of the second term divided by the first term. So we'll use exactly same thing to find here. The top remains 10. This one will become under root 1 over 20 omega square, which will become 400 omega square. And the angle will be tangent inverse y over x, that is 20 omega over 1, is 20 omega. So Z we have found. Now we can find the voltage here, which will be I times Z. So with this we just multiply by I. We don't know as yet I phasor. We have to apply them each one separately from here. Okay, so now let's further discuss the current given. This is the DC current and this part is the AC current. So the DC current is 2 ampere and we can find the DC voltage from this equation. by putting omega is equal to 0, because we know that at DC omega is 0. So omega is 0, and here we put 0, this one is also 0. So tan angle 0 will be 0, this term will be 0. So it is 10 into IDC, that is 10 into 2, which is 20 volt, angle is 0. So this is the voltage and current in DC. And now for AC, as I mentioned earlier, here omega is 1 and here omega is 3. So for omega 1, our AC part will be, we'll call it IA, so 10 magnitude, angle 10, this is IA. And VA, again in this formula, will put omega is equal to 1. So this is the value, and this solving, we get magnitude 5 minus 77.14. And this you can easily do by using your calculator in complex mode. So let's see, it is already in complex mode. If you want, you can press mode and then 2 for complex. So it is in complex mode. The angle has to be D for degree. And now let's write this. Stop, 10, bracket, 10, angle shift, this is angle sign, shift angle 10, bracket close. So the numerator is done. Let's come to the denominator. Bracket under root 1 plus 400, bracket close. And then the angle, shift tangent inverse from here, tangent inverse 20, bracket close, move ahead, equal sign. There is an error, go back and see. Okay, so this is small bracket, should not be there. Okay, done. So this is now in rectangular form. We need the answer in polar form, so we'll press shift 2 for complex, this is complex, and 3 for r theta, 3, equal sign, and this is 0.57, so there is something wrong in my calculation. I have to do it again. Now, let me go to the top, and we can just multiply these two. So we write 100, shift angle 10, coming to denominator, bracket underscore 1, under root 1 plus 400, bracket angle shift angle tangent inverse shift tangent inverse 20, bracket and then shift complex 3 for r theta. Okay, now it is 4.993, which is 5. and then angle is minus 77.13 to minus 77.14. So this is the answer. And now for omega 3, exactly same technique. This is the magnitude and angle for I. Here we will put omega 3, putting the value of omega 3 and solving. V3 will be 1 angle minus 54.04. So in time domain, our voltage now will be the DC voltage 20, this AC voltage magnitude and phase angle. So we'll write it cosine, and this was for omega is equal to 1, so 1t minus this angle. Then the second part is magnitude 1 cosine. This was for 3t, so 3t minus this angle. Okay, now we have to determine the average power, and as I mentioned earlier, that we can do it by finding the power supplied, which is equal to power absorbed, or you can also just calculate power absorbed and then find power supplied. So this is easier, but we'll do all three so you can follow. So the first method is given in the book. So what he has done is just written the power equation. And now one thing which is making it slightly complicated is that he is saying that you have to find the sine of the angle, proper sine of the angle. And to do that, we have to compare it with equation 17.42 and 17.43. Let's do that. This is 17.43. This is our voltage equation. So if you compare now, this is minus, this is also minus, that means theta 1. This is for theta 1 or omega 1. So theta 1 will be plus 77.14. Similarly, this one, when you compare with this, theta 3, actually not 2, theta 3 will be 54.04. And similarly, for the current, comparing with the current equation, this equation, then here you can see phi is minus and this is plus, therefore we have to write phi 1 is equal to minus 10, and similarly phi 3 will be minus 35 from here. And now we'll plug in these values into the equation. For the VDC, we have already seen that it is the current multiplied by the voltage. The voltage was 20, current was 2, then half. Then for the first harmonic, that is n is equal to 1, V and I, the V magnitude is 5, I magnitude is 10, so 5, 10. Cosine of theta n minus 5n. Now theta n is how much? From here you can see 77.14 minus of this, minus. So this way you can write the first one, and similarly for the second one, and solving you can find this answer to be 41.297 watt. On the book, the answer is 41.5, which is wrong. This is the correct answer. Okay, but I think that there is a simpler way of doing it. We already know that V cos can be written in terms of phasor is the magnitude and angle. And similarly, current can be written as magnitude is angle. And the average power for AC part is half Vm cosine theta V minus theta I. So we can use this formula. And in our case, we had found these values of current and voltage. So we'll plug in the values. PAC, first of all, we'll find will be half V1 with the omega 1, I'm calling it V1. V1 I1 cosine theta V1 minus theta I1. So this theta and this, let's plug in the first one. So half V1 is 5 magnitude, I1 is 10 magnitude, and then theta V minus theta I. So theta V is minus 77 and I is 10, so minus 10. And similarly, in the other case, V3 I3, so it is 1 and 6, and theta V3 is minus 54, minus 35, and solving you get the same answer. This is for the AC. Now we add the DC power 40, and so the answer is exactly same, 41.297. And now the easiest method is if you find the power absorbed. The resistive load absorbs power at all time, while the reactive load L or C absorbs zero average power. We have to keep in mind this. We need to only calculate the power absorbed by the resistor. We can find average power absorbed by the resistor by following this formula. DC V over R, V square over R is the power. Similarly for AC also, Vn square over R. And plugging in the values, now we're dividing this into two parts. For omega 1, we're calling it V1. For omega 3, we're calling it V3. And putting the values here that we have got. VDC 20, V1 is 5, and V3 is 1, all divided by R. And solving here also we find the answer 41.297. I hope you have been able to follow this. Please let me know through your comments, and let me know if you need any other questions to be solved. And are you clear about the concept of harmonics? If not, let me know. I can try to help you. Thank you.